Good morning, everyone. It's my pleasure to be here. One of the things I wanted to start out my talk with this morning is kind of reflecting back on Eric's message that he had yesterday, really looking at the three pillars of what builds Bioman's business, really the service, speed, and science. So that's one of the things I'm going to focus on today is the science part of that. Myself, I never planned to get into mycotoxins. It was partly through collaborations with Bioman, and I want to thank them again for really challenging me as a scientist and how I think, how I approach things, and at least giving me some perspective, at least on practicality and purpose of science. And that's where I'd like to focus at least today. Getting into mycotoxins are a very difficult area to essentially delve into the science. I think us as scientists need to delve into the truth, trying to uncover things that are not known. And I wanted to talk about some of the difficulties, at least, in studying mycotoxins and some of the challenges, at least, that we faced and are facing in this area of science. Still, many places in the world, as you see these pictures on my first slide, as we think of mycotoxins, we think of clinical lesions. And we need to realize that there are things that are happening as we delve into the area of mycotoxins well beyond those clinical lesions that are affecting our profitability and bottom line in our industries. So the question that was posed to me today was, and we've been researching over the last few years, is really, do mycotoxins affect the gastrointestinal tract? This is not an easy question to get at, especially this afternoon we start talking about how we determine and analyze gut health. Part of the reason this is difficult as a scientist really is you look at using naturally contaminated sources. We need to realize as we go into experiments that likely that's changing the nutrient content of the feedstuffs themselves. So we need to understand differences between those nutrient densities because of the mold being present versus those that are causing effects due to those mycotoxins' presence. In some cases, especially with swine, ruminants as well, not so much with poultry, we do see differences in feed intake because of the presence of mycotoxins and the presence of that mold. You have to understand when we go forward with experimental designs that we need to be able to understand the differences attributable to feed intake behavior versus those of the toxic effects of those mycotoxins. We also need to know, at least to understand the question posed to whether it's affecting the gastrointestinal tract, is we have several effects that are happening to other organ systems beyond the level of the gastrointestinal tract. Those then relay effects then to secondary effects on the gastrointestinal tract, which makes it very difficult to try and tease those things out. And across the different mycotoxins that we have differences in absorption. Some are absorbed very rapidly, and we'll talk about those, versus those are virtually non-absorbed. And in some cases, we'll talk about, in the case of Fumonisin, we had traditionally thought that they had no effect on the animal because of those low absorption rates. As we begin to discover, those are inherently not the case. So to start this discussion, to give you an idea of some of the quandaries we have from approaching this science, is really looking at the nutritional quality of corn. We know in some cases, as the example here, just one batch back from 1983, inherent differences in energy content, protein content, and fat content from normal versus moldy corn. Taking this to an experimental design, we know inherently to try and understand some of those toxic effects of that compound, if we include them at similar rates, we know that that will inherently lead to a confounded result. So building these experiments becomes very, very difficult. I wanted to point towards a publication that Bertrand Grenier, he was from Isabella Oswald's lab in Rennes, France, another Bioman brain winner. And then he came to spend a postdoc with me for 3 years when I was at Purdue University. And one of the things Bertrand did, and the last World Nutrition Forum, he did a wonderful job presenting some of this work as well, was really to put in perspective some of the things that we know now versus inherent historical things that we've seen within the literature, particularly as they affect the gut. And again, beyond the clinical symptoms that we tend to see with many of the mycotoxins as we think of them today. So to preface a lot of this conversation, I wanted to remind everyone that the gastrointestinal tract is a very energy and nutrient rich source, and therefore the maintenance to it is very strenuous, particularly from a protein standpoint. Protein turnover is at 50 to 75% per day, and 25% of every protein produced within the body is secreted into the gastrointestinal tract. And just as a reminder, many of those mycotoxins that we look at inherently have effect on protein synthesis. So this was the mindset that we were looking at least as delving into that of how mycotoxins affect the gastrointestinal tract. So Bertrand essentially created this meta-analysis across the literature from 83 different published sources across all livestock species, as well as in vitro studies, focusing on different effects within the gastrointestinal tract, whether it be nutrition or defense mechanisms. For any of you that are interested, you can probably contact Biomen or myself, and we'd be happy to supply this to you from back in 2013. Inherently, as we look at those effects across the different mycotoxins, we realize that most of the literature is published effects of deoxynivalenol on the gastrointestinal tract itself. So as we start to break apart how different mycotoxins are affecting the gastrointestinal tract, it's good to reflect upon how these mycotoxins are actually absorbed as to it relates to where they are going to have potentially some of their impact on the gut. If we look, whether it be the pig or the bird, we know that aflatoxin, as an example, is very rapidly absorbed, and over 80% of that aflatoxin is absorbed very rapidly in the very upper part of the gastrointestinal tract. As opposed to deoxynivalenol and fumonisin, which absorption rates are much, much lower. In the case of the bird, which I do a lot of research with, we see roughly about a 1% absorption rate, although we do see increases due to enterohepatic circulation that then increases those concentrations as that digestive moves down through that digestive tract. So I'd like to focus at least first on aflatoxin. I'll come back to deoxynivalenol and fumonisin in a little bit, just to give you an idea of some of the things that our lab and some others have been looking at. The one thing that we need to as scientists, and I consider everyone in this room a scientist, so I'm going to challenge you a little bit, by being reflective of things we know now, but putting them in perspective on historical research that's been done. And oftentimes this iterative process, we do not take the time to go through that exercise. So I'm going to go through that exercise a little bit with you this morning, if I could, just to make sure that we all have this capability. The one thing with the Biomen surveys that they've been doing over the past few years really has given us a perspective across the world of what are realistic doses from different mycotoxins, what are occasional doses, and what really are unrealistic doses. So us as scientists that actually do research with mycotoxins in animals, we need to realize concentrations that we're using are much more within the area of occasional doses or realistic doses and the effects that might translate to the animal. We then often have to question whether some of those unrealistic doses we would ever encounter, and some of those effects may or may not be realistic in and of themselves. So with that as a background, we need to go back to the literature and understand some of the things that we think we convey from mycotoxins are indeed true. So I'll go back to a publication. This came from North Carolina State University and University of Georgia. This was an abstract presented back in 1975, so fairly old. They were feeding 5 to 10, anywhere from 0 to 10 parts per million of aflatoxin. This abstract, as it was presented, and I've highlighted a few areas here, that pancreatic lipase was thought to be the major fat digestive enzyme, was decreased at all levels. Fecal fat was decreased at the very highest level. So the summary was that aflatoxin appears to cause malabsorption syndrome. So one of the easy things today with information overload that we have in today's world is that it's very, very easy to focus on the last statement, right? So we need to realize as well that this is a small number of researchers' interpretation for what they understood at that point in time. Oftentimes that becomes dogma that we believe, but we don't take the time to go back to challenge or look at that literature and put it in perspective for where we are now. So let's do that. Let's go back and put that in perspective if we can, just so we understand where we are, knowing today's dosages for aflatoxin on what is realistic, what is occasional, and what is unrealistic. So as we look back, they did include a range of different mycotoxins across this particular study, all the way up to 10. So we see that pancreatic lipase did have an influence, or the aflatoxin did have an influence on pancreatic lipase, but only fecal fat was affected at 5 to 10 parts per million. So as we go back, we need to put that in perspective. This makes us very difficult to try and tease out. At least we know that there are some physiological effects in the gut are affecting pancreatic lipase. The question is this measurable, at least when we look at fecal fat and or energy use by the animal in our experimental settings? We dig in a little bit more as we progress through the literature. Here we see from Osborne and coworkers in 1982, as we look at those maximum occasional doses, we need to realize that with ochratoxin, we are not seeing much of an effect here on bile output, but we are seeing somewhat of an effect on that of aflatoxin. Looking at other physiological functions, at least, as we look at lipase, we do see some effects, especially with aflatoxin, but not so much with ochratoxin. And in the case of that of trypsin, again, no effects in the case of T2 or ochratoxin, but mild effects then of aflatoxin there on trypsin production. So that's the challenge to you within the audience. Don't be afraid to get into the scientific literature. Don't take the presumptions and summaries of those authors for granted. Make sure that you go back to put things into perspective. And I think that's important for us to go through that iterative process as scientists. And partly because as we dig into our ability to be able to analyze and have more real-time information available to make decisions, we need to be able to differentiate. And this is a slide that's been used for different things, but we often think of this as an iceberg. Really, that those clinical mycotoxicoses and lesions are something we can actually see, but realize that there are other things that are subclinical that are affecting probably our bottom line. Another way of thinking this as well, sometimes that performance differential that we may be able to pick up, maybe not, is only part of the bigger picture. That us as scientists, I think one of the things moving forward really is delving into biomarkers and how they are affecting the functionality of the animal, particularly as we're moving into eras that our animals potentially could be placed in antibiotic-free environments, potentially facing larger gut challenges, and then potentially impacting performance. So for us as scientists, it's incumbent upon us to figure out what those biomarkers are that then do translate into actual performance differences. So back to aflatoxin, if you will, and some more recent work that we've done at my prior institution with one of my last graduate students from Purdue. She was interested inherently of what aflatoxin had on endogenous amino acid losses and nitrogen loss. And she noted through this particular study, at least, that we were seeing an increase in endogenous protein loss of nearly 28% when aflatoxin was present. Again, that being an occasional dose, if you will, of aflatoxin. But as we were digging in, we were looking more towards biomarkers. Biomarkers in particular of indicators of gut function and gut health. Here is an example that one of the traditional measures that many people make is that of histology, just looking at villus heights and crypt depths. Nothing very dramatic, at least, from impacting how those intestines were appearing from a microscopic level. Some mild differences, at least, as we were getting above 1 part per million, at least in crypt depth, possibly indicating that some things were going on, but not very definitive in and of a single measure. We began looking then at perturbations, and we've talked and heard, at least yesterday and today, a little bit about mycotoxins' function and impact then on permeability through the gut. And the interesting thing that she was seeing here, at least, in using 2 different sugars, one of which should not go through the transcellular or the paracellular route, it goes in between. So at lower protein concentrations, we were seeing impact, at least on gut barrier integrity, but only when the level of protein was compromised for that animal, that it wasn't then able to have the resources from an amino acid base to fully synthesize those. Wanted to shift attention now, if I could, to 2 mycotoxins, those of deoxynivalenol and fumonisin. Again, back to that meta-analysis that Bertrand did back in 2013, a lot of those publications in particular were looking at deoxynivalenol, not necessarily fumonisin, but realized with deoxynivalenol in a pig, we're seeing roughly about half of that being absorbed, 5 to 20% in the case of the bird, and with fumonisin, roughly about 3 to 5% being absorbed in the case of the pig versus only 1%. So the question comes to, does that mycotoxin, as it moves through the gastrointestinal tract, actually have some translated effect on the gut itself? And that's a very difficult question to get at. We know that in many cell culture studies, with much higher concentrations, we are seeing some perturbations to how that gut functions. The question is, as you take it to the animal, whether those indeed are then translated into the animal itself. So one of the measures and biomarkers, at least in the case of fumonisin, we have the luxury of at least having some very well-known biomarkers, and that's the interruption of the sphingosine metabolic pathway. So sphingolipids are very important for integrity of that cell, and we know from some documented work that actually happened in Athens, Georgia, where I am now, that interruption occurs because of interruptions to particular pathways, and we do see a change then in what's called the sphingonine to sphingosine ratios. So Bertrand, when he was with me, one of the exercises he went through was just to look at concentrations and then how that affects the case of the bird. He did somewhat similar work when he was at INRA in France. So he picked different tissues, serum, kidney, liver, lung, cecum, jejunum, and ileum, as we fed different doses, just to see how that affected the particular biomarker. And you'll note that here in the ileum, again, so this mycotoxin, which we thought was having no effect on the gut itself, is having a fairly dramatic effect of all those tissues on this biomarker in the ileum. So inherently, we know it's having an effect. The question that we need to ask now and have asked is, does that translate then to functional differences that impact the integrity of the gut and the animal itself? So Bertrand was one of those guys in the lab that liked to make a lot of measures. And he made a lot of measures. He's very detailed in his science. And with an immunology background, I think it was very good, because one of the things that he began looking at with those concentrations in the ileum really was what it was related to. And one of the things that he noted at that point was that it was inherently related to an increase in expression of inflammatory markers. Along about the same time, there was other research groups throughout the world that have looked then, as you put that animal into somewhat of a challenge state, do those increases in inflammatory markers and our biomarker that we're measuring here have an impact on functionality of response of that gut under challenge. So back up a step, if we talk about permeability in particular, we know that there are two different routes of permeability, and those of you in the swine session yesterday when you saw Nick give a talk, Nick Gabler, he talked particularly about impairment of permeability either through the transcellular route or through the paracellular route. And we know in some cases from research with deoxynivalenol that it can impair some functions, at least from the transcellular mechanism, but particularly from the pericellular route as we look at these tight junctions that act as gatekeepers, if you will, between the cells to mitigate how compounds and substances go between those two different cells. We do know that if they are impaired, that it can lead then to impairment and higher translocation of different antigens, flora, and different pathogens and antigens, toxins, and mycotoxins through that barrier. So as a poultry scientist, I wanted to make sure that my fellow poultry people didn't throw anything at me because this is one of the few swine studies that I've ever done. So these are swine jejunal cells. And I had one very good researcher with me from China that was visiting, trying to understand mechanisms, at least, of why, through the literature, we were seeing deoxynivalenol actually breaking down some of those tight junctions as barriers. So this is not very new, but we needed to form the basis for some of our experiments, really looking at transepithelial resistance, and you can see that as time progressed, deoxynivalenol tended to perturbate that electrical resistance between those cells. And then as we looked at a marker using a fluorescent dextran to see how much went through, we saw a dramatic uptick in that perturbation or compounds actually being able to translocate across that gut. But part of the question was why? What is it doing, at least within that mechanism, to break it down? And one of the interesting things that she found was that there's a particular family of tight junctions known as the claudins. And what she saw through a number of her studies was that very, very quickly upon exposure to deoxynivalenol, the degradation of that family of mycotoxins, or that family of tight junctions, decreases quite readily. What the cell does to try and respond is it tries to create mRNA or message to be able to create more protein. But the creation of that protein does not happen quickly enough versus the degradation, and that leads a little bit to that difference in tight junction that we see. So fast forward a little bit to some of the work that Bertrand did to understand then, we see these mechanisms that are happening at least in cell culture. We know that there's perturbations to those tight junctions, and the question comes to when that gut is challenged, do we see any logical effects that then make that animal more susceptible to a particular disease state? In the bird, at least, one of the biggest things we're faced with is that of the protozoa Emeria. This particular study, we were looking at challenges and again trying to keep them, again, at those occasional doses. Here we were seeing 2 parts per million of DON, 20 parts per million of Fumonisin, or the combination of the two. As you can see across lesion scores of those challenge birds, we're seeing that regardless of which mycotoxin was present, we're seeing increased severity in lesions. As we look at number of oocysts present in the mucosa or excreta, we tend to see increases as well when those mycotoxins are present. So that essentially tells us that severity has increased. The question is partly why. The other thing in tandem that we saw, going back to the biomarkers, was that within the ileum and the liver, in our challenge birds, we're actually seeing an increase in that biomarker within the liver, suggesting then that it's acting as a conduit for passage of those mycotoxins then into systemic circulation, potentially then have greater effects than on the animal itself because of reduced barrier integrity. One of the things that he also did when he was with me, he reached out to Ramesh Selvaraj at Ohio State University. Ramesh gave a talk yesterday in the poultry section, just to fully understand the immunological ramifications of some of these inflammatory responses to the animal. And I think the most interesting thing in the take-home was that what's termed the T regulatory cell process, it took much more of that process to essentially curb that inflammation in the presence of deoxynivalenol. So we're seeing increased translocation, increased need to essentially curb that inflammatory process at the level of the gut. And this is translating, at least I think, to some of the effects that we're seeing. Again, these are at those occasional doses. The question is, what is present in your geography at your point in time as to whether that manifests itself then upon challenge by the animal. Now, as a scientist, I tend to be fairly skeptical as I approach a new area of science. And I would encourage you to also be somewhat skeptical, but inquisitive. I tend to believe some of my results if I tend to see someone that I haven't collaborated with see and do something very similar and see the very similar trend in some of the results that they have seen. So Gunther Antonsen at the University of Ghent had been using a necrotic enteritis model for a number of his PhD level work, also in collaboration with Bioman. His model here, he used deoxynivalenol alone. Here you see the CP is Clostridium perfringens, or the combination of the two in their model. And as you can see here, you see with the birds with deoxynivalenol had over 2 times the amount of lesions in those particular birds. As you see oocyst counts and lesion scores, you see an increase in that severity when deoxynivalenol is present. So the model that they came up with to try and fully understand this back to that integrity of the epithelium really is somewhat intriguing. That necrotic enteritis in the case of Clostridium perfringens exposure, when you put the two together in a petri dish, the perfringen does not necessarily produce the toxins. However, when you put it into the animal itself, you see an increase in the biofilm of Clostridium perfringens. Partly what we think is happening is through perturbations to those tight junctions to increase plasma amino acid leakage into the lumen of the gut. So at least we know that in the case of pigs and poultry, this is not the first, when we put those combinations of mycotoxins together, that there is a bevy of literature to suggest that there is a higher sensitivity to different parasitic as well as bacterial disease challenges when these mycotoxins are present. So to conclude, kind of back to my original question that I had posed as the beginning of my talk, do mycotoxins affect the gut? Well, yes, they do. But we really need to understand first which mycotoxin and think about where it is affecting and being absorbed within the gastrointestinal tract. 2, what the concentration actually is. And what is the concentration that's realistic in your world? And then 3, really what routes of effects those mycotoxins are having on the gut. It's inherently very difficult, at least from us as an experimental standpoint, how to make sure that those experiments are not confounded. Particularly from how those changes to nutrient and energy content within the feedstuffs then affects the outcome. Changes to feed intake behavior potentially could affect that outcome of the experiment, or potential changes to metabolism therein. And I'd have to say there's a lot of work to be done in this area. I think it's optimistic, at least for me as a scientist, that there are a number of things that we need to relay, particularly in combinations of different mycotoxins, and 2, how those interact with pathogens within the gastrointestinal tract. So I thank you again to Bioman for inviting me here today to share some of these thoughts with you. And I turn it back to Dr. Schatzmeier.